All right, this is question number 8 on the problem set for Module 7 having to do with prokaryotic gene expression. And in this question, the table is presented like this with a number of genotypes. In this question, these are merodiploids, partial diploids. So there are 2 copies of the lac operon. And the genotype here shows 1 copy, plasmid copy on the top, and chromosomal copy on the bottom, okay? And then it asks the question for both LAC-Z and LAC-Y, is expression inducible, not expressed, or constitutive? So these 2 may show the same or they may differ, depending on the genotype. All right, so what's the answer? So first of all, for the first genotype here, both copies are fully wild type, okay? So there's a wild type repressor, and this repressor is able to bind to the wild type operator, but if lactose is present, it's going to change the shape of the repressor, and that repressor can't bind to the wild type operator. So for this genotype, it's going to be essentially wild type genotype times 2. So for both LAC-Z and LAC-Y, expression of beta-galactosidase and lactose permease is going to be inducible. Inducible expression for both. Okay. And number 2 is showing basically the same thing, except the only mutations are in the coding genes for LAC-Z and LAC-Y. 1 copy, the plasmid copy, has a null allele of LAC-Y, but the chromosome copy has a wild type allele of it. For LAC-Z, the plasmid copy is wild type and the chromosome copy is null. All right, so the mutations are present for both coding genes. However, there are wild type versions also present. The regulatory, make sure I got this right here. Yeah. The regulatory sequences, so there's a wild type repressor on the plasmid, null repressor on the other. Both of these contain wild type operators, okay? So, the situation for these is what we see inducible, not expressed, or constitutive expression. All right, because both of them have wild type operators, these operators are able to bind to wild type repressors. So there is a copy of a null repressor, however, there is also a copy of a wild type repressor. Wild type repressor is diffusible, so this is going to be produced in the bacterial cell, and it's going to diffuse around, and it can bump into either of these copies. Both of these copies have wild type operator, okay? So in the absence of lactose, this repressor is going to be binding to both operators, and the operon will be off. In the presence of lactose, lactose is going to be able to bind to repressors present at both of these operators. And it's going to pull the repressors off. So this is going to be the same as the first one. This will be inducible expression for both. Okay? Doesn't matter which copy, which operator the wild type LAC-Z, LAC-Y or LAC-Z is linked to. Both of these are operating fully functional operators, and there's a fully functional inducer. All right, let's look at this example. In this example, LAC-Z plus is on the plasmid copy, LAC-Y plus is on the chromosomal copy. For the regulatory sequences, both functional operators, but we have a super repressor. Okay, super repressor is not able to bind to lactose, allolactose, the inducer. Okay, so this super repressor will constantly be bound to the operator, and there's no way to pull it off because there's no binding site for lactose or the inducer. Okay, so that means there are both functional copies of the operator. That means the super repressor is constantly going to be bound to this, and it can't be induced to come off. So for both of these, there's no expression. All right, so far both of these genes are being, kind of regulated the same. All right, let's look at this one. And so the plasmid here has an operator constitutive mutation. Constitutive mutation is not able to bind to the repressor. But the chromosomal copy has a wild type operator. The wild type operator is linked to the LAC-Y gene, and the constitutive operator is linked to the wild type LAC-Z gene. And the repressor is both wild type. Okay, that means it's able to bind to the operator and to the inducer. So, for the situation for beta-galactosidase, the LAC-Z gene, because this is linked to the operator constitutive mutant, this operator can never bind the repressor, and so this operon can't be shut off. The LAC-Z gene, therefore, will be constitutively expressed. The LAC-Y gene on this operon is mutated. Okay, so let's hold off on that one for a minute. So for LAC-Z constitutive expression. For LAC-Y, the LAC-Y positive wild type allele is linked to the wild type operator. This operator can bind to the wild type repressor. In the absence of lactose, in the presence of lactose, the repressor will be pulled off. For LAC-Y then, this will be inducible expression. Okay? So that example, they differ. Final example is, what if the plasmid copy here with wild type LAC-Z is linked to a constitutive operator, but it's also in the presence of a super repressor. And so the chromosomal copy has the super repressor and the wild type LAC-Y gene. All right, so now we're mixing it together, two mutations. Here's the OC that can't bind to the repressor. The super repressor would normally be bound to the wild type operator and not able to be pulled off because the binding site for the inducer is mutated, can't bind to the inducer. So let's look at the top copy here. The operator constitutive mutant, the binding site for the repressor is mutated. So it doesn't matter if the repressor is a super repressor or not. This cannot bind to this operator because the binding site for the repressor is mutated. So this operon is always going to be on, always be expressed. And this constitutive operon is linked to the LAC-Z wild type allele. The LAC-Y is null on this copy, so for now, LAC-Z is going to be constitutively expressed. The LAC-Y is linked to a wild type operator, and however, there's also a super repressor present. The super repressor is going to diffuse through the cell. It's a transacting factor. And the LAC wild type operator is going to determine the expression of LAC-Y because it's physically linked to it on the same copy, and this is a cis-acting factor in the operator. Because of the presence of the super repressor, it's going to be constantly bound, can't be pulled off, and the LAC-Y, therefore, is not expressed. Okay, so that's kind of the thought process you should go through when you evaluate these kind of merodiploids and the different genotypes.